So inequalities are a similar idea. They're still saying how one side balances or compares to the other, but now they're not the same. Now one side's bigger than the other, or smaller than the other, or smaller than or equal to the other. There's a range of answers that work. So let's think about the difference between x equals 3 and x is greater than 3. The equation is saying that x is one number, x equals 3. There is no other number it could possibly be. X does not equal 4 or 5. It's just that one number. The right side, the inequality, is saying that x is bigger than 3. Actually, 3 doesn't even make sense there. 3 is not bigger than 3. This is not true. 3 is not bigger than 3. There's a whole range of numbers that do work. 10 is bigger than 3. 11 is bigger than 3. Any number bigger than 3 works for that. So for an inequality, there's a range of numbers that work. For an equation, there's one number that works. So that's the difference in interpreting the answer. But there's only one difference when we solve an equation versus an inequality. Inequalities are solved the exact same way, but when we multiply or divide by a negative number, only multiplying or dividing by a negative, we must flip the sign. So these are the 4 signs that we're going to be dealing with. When we read this is said greater than. This is less than. This is greater or equal. And this is less than or equal. And the title of the table is saying when we graph it, what does the dot look like on top of that point? So let's say we had x is greater than 3. You would put an open dot over 3, and if it's greater than, then the arrow is going to point this way. That's a really easy way to remember this. If it's less than, it's going to point that way. The problem is that doesn't work all the time. It only works when the variable is on the left side like this. If we flip this around, if we rewrite this as 3 is less than x, it's the exact same idea. It's still saying that 3 is less than all values of x. 3 is less than 5, 3 is less than 10, 3 is less than 11. But you can't just follow this arrow now. You have to think about all the values that are greater than 3. So on this first one, we're going to graph that. We're really just going to put the number right in the middle, put 10 there. It's going to be a closed dot. The reason it's filled in, it's a closed circle, is because x could equal 10. It's greater than or equal to 10. So we're going to fill in that dot saying that this point actually does work. Also, all of the points bigger than 10 work. X is greater than 10. Anything that's bigger than 10, so 11, 12, all of those numbers are also a solution to that inequality. The next one, we're going to put an open circle above -7. X can't actually equal -7. -7 is not less than -7. That doesn't make any sense. But all the numbers smaller than -7, -8, -9, those are all solutions to that inequality. They're bigger negatives, so they're actually smaller numbers. So this is the example I was talking about before where we have that sign flipped. If you want to rearrange this, you can. Make sure you flip the whole thing though. You put x on that side, you flip the sign, and you put the 4 on the other side. This is probably easier to graph. X is less than 4. Put 4 there, an open circle, and it's all the numbers smaller than 4. The trickier step is when we actually have to solve something and then graph it. So we need to be really careful when we solve it. We're still thinking about order of operations backwards. We still want to think about what's directly attached to our variable. What's this dividing by 4? That's the closest thing to our variable. So we really want to get rid of the other number first. We're going to get rid of this -5 first by adding 5 to both sides. So x divided by 4 is less than or equal to whatever 4 plus 5 is, that's 9. We're going to keep that sign the same. All we did was add. Now we have dividing by 4 that we want to cancel out. We're going to undo that by multiplying by 4. Those cancel out. We're dividing and multiplying by 4. Those are gone now. We have x is less than or equal to 36. I don't flip the sign at all because I'm multiplying by a positive number, not a negative. So this is saying that x is less than or equal to 36. I put 36 on the number line. I'm filling it in because it could equal that, and it's all the numbers that are smaller than, or all the numbers less than 36. So we could say 0 is a solution, or 18 is a solution. Anything that's less than 36 is a solution to that inequality. The next one, I'm going to choose to flip this right away. And the important part is that you flip the inequality. We want to flip the sign, but we don't want to change the order of any of the operations. We want to keep every operation the same. I'm going to keep this exactly as it is. I'm going to rewrite that as 3x plus 1, flip the sign, and rewrite that just as negative 11. I think this is easier to solve. If you want to keep it the other way, you can. You just have to be mindful of graphing it and thinking about the solutions. I'm going to solve it this way by getting rid of whatever's not directly attached. This is directly attached. The 3 is directly attached, so I'm going to get rid of that plus 1 by subtracting 1. It gives me 3x is greater than negative 12. And 3x is really multiplication. I want to undo multiplication by dividing. So x is greater than negative 4. I didn't flip the sign. I don't care about the negative 12. That's not what I'm talking about when I'm dividing or multiplying by a negative. It's really the 3 that I'm talking about. That's a positive 3. We don't flip the sign. We only care about the number that's attached to the x. If that's a negative, then we're going to end up flipping the sign. Okay, so we put negative 4 on the number line, and it's an open circle. And all the numbers bigger than negative 4, so negative 3, negative 2, all are solutions. That's basically what we're going to be dealing with on 11 and 12. We want to figure out on 11, shading all of the ones that are solutions to the inequality. And number 12, we're going to figure out all the numbers that are not solutions to the inequality. There's a couple different ways you can go about this. You could take all 8 of those numbers, plug them in for x, and see if you get an answer that's greater than or equal to 2. So actually, I'm going to do that with just one of these, because that's kind of a hassle. I don't really want to do it that way, but I'm just going to show how you would do that. 0 divided by 3 plus 1 is greater than or equal to 2. If it's a solution, then that's going to be a true statement. Basically, the left side is greater than or equal to 2. If you plug that in, 0 divided by 3 is really just 0. So that's just 1. 1 is greater than or equal to 2 is not a true statement. So I know 0 is not a solution to this. There's a much faster way to do this. So we could go ahead and plug in the rest of the 7 numbers. I'm not going to do that. I'm going to solve it by getting rid of first what's not directly attached. So that 3 is directly attached. It's being divided. I'm going to get rid of that plus 1 first. I'm going to subtract 1 from both sides. That's x divided by 3 is greater than or equal to positive 1. Now I want to undo division with multiplication. That'll cancel out that division. We'll multiply by 3 on the other side. X is greater than or equal to 3. Again, we didn't flip the sign because we didn't divide or multiply by a negative. We're looking at all the numbers, all the solutions that are greater than or equal to 3. Well, 3 is greater than or equal to 3. And then anything bigger, 4, 5, 6, and 7 are all greater than or equal to 3. Number 12 is the exact opposite question. It's talking about which ones are not solutions. Which ones don't make that true. So again, we could plug those numbers in. I'm not going to do that. That's more work than just solving. So I'm going to get rid of whatever's attached to it as my last step. That negative 5 is what I'm going to deal with last. Actually, right away, I recognize that that sign is going to flip. My inequality sign will definitely be flipping in this problem because the number that's attached to the x is a negative. We'll deal with that in a second. But right now, we'll get rid of the number that's not attached, which is this 2. I'm going to do that by subtracting 2 on both sides. That's negative 5x is greater than 30. And now we're going to divide by this negative 5. This is multiplication. We're going to do that with division. And this is the only time when our inequalities are different from equations. We flip this sign, giving us x is now less than negative 6. So all the numbers smaller than negative 6. This is kind of a counterintuitive idea, but it's actually the bigger looking numbers. On a number line, it's the bigger negatives that are smallest. Negative 10 is smaller than negative 3. So negative 10, negative 9, negative 8, and negative 7 works. Negative 6 does not work. This is a really confusing idea because sometimes when you guys solve this, you don't write out all your work and you just get the answer negative 6 and you just think that's got to be it. But it's saying that x is less than negative 6. It's actually saying it's not negative 6 at all. It's all the numbers smaller than negative 6. So you can't just take that answer and think that that's right. You have to think about all the numbers that are smaller than, all the numbers that are less than negative 6.